G'day. I'm up at the World's End State Park in Pennsylvania. Pretty nice park. Doing a little bit of AI, mainly just walking around here. It's much too nice to be inside doing AI at the moment. But for this video, things I'm going to look at is to add some MCP or agentic services to my AI system. So you've seen the hardware in the previous video, basically running a Jetson Nano for running the LLM using Ollama, and then got a Raspberry Pi in the front end to run client services. Something I want to do for my camping agent is to be able to get the current time, get my current location using a GPS, and get things like distance to the nearest state parks and distance to the nearest RV parks that are around me, to make sure I don't have hallucinations coming from my AIs, especially seeing they're such small ones. It's best to do that with something like function calls to services that provide the information in the context. And very recently, these services have been standardized to use a protocol called MCP. So that's what I'll be showing you in this video, is setting up MCP services to get the current time, current location using a GPS, and use my database of state parks and RV parks to get distance to the closest ones.
Okay, let's have a look at how this is all going to be put together. So I'm using the same two pieces of hardware I showed you in the first video. Jet AI is a Jetson Nano computer that's running Ollama. That's going to host LLMs that I'm using. That's available on port 11434, which is the standard Ollama port. And then the Raspberry Pi, I'm calling Pi AI. That's going to host a bunch of services specific to what I want my Scamp AI agent to do. So first thing is I need to know my current location. I'm going to add some GPS hardware to get the current location using GPS, and I'll put the results of that as it gets each location into a GPS.json file. So this will always have the most recent longitude and latitude of what my location is that was successfully received. The rest here will be services that will be provided that the Scamp AI agent uses. So the services are going to be available as MCP services. MCP is a recent addition in the AI world. It's been around for about a year, but it's made being able to do function calls outside of an LLM more consistent. So there's now a standard protocol for being able to discover what services, or they call them tools, are available outside the actual LLM, and how you call those. So all that's been abstracted and made a lot easier. I'll show you how we build some of these, but the services I'm going to have is a time and location service, service to get Pennsylvania State Park information, and the same thing, a service to get just general RV park information. So when I want to get something like the current time, I'm going to have a real-time clock running on the Raspberry Pi, so I'll always have the current time, and so I can just call the service and get that from the Raspberry Pi. And same thing for location. If I want to know my current location, I'll have a service that goes out, reads this GPS JSON file, and returns the longitude and latitude. Other things here, so there's PA state park information. So this will be a service that provides information about what state parks are a certain distance from a location that I pass it. So I'll probably pass it a longitude and latitude again, and it'll be able to find state parks. It'll also have some filter capabilities, so I can say, hey, I only want to see state parks that have RV camping. So that's one of the services. The other service will be just a general service to get RV parks, so not state parks, but RV parks that are a certain distance away as well. I'm going to have about 4 states worth of RV parks, but again, they'll be exposed as an MCP server, and this agent will be able to make use of these tools, as well as the LLM. LLM's going to be providing things like real language processing and some reasoning capabilities to make use of these tools, but then the specific data that I want to use will come from the tool, so that should cut down on hallucinations as well. So rather than the LLM making up what state parks are out there, I'll tell it to actually only use the state park information to get that data, so I should only get real data coming back. For the front end of this, at the moment I'm going to be using Open-WebUi as my front end to this. It has capabilities in there where you can set it up to connect to Ollama, make use of the models out there, as well as tie into MCP services. So I'm going to use that while I'm testing this. And then probably in a later video I'll look to make a what I'm going to call Scamp AI client, hopefully running an Angular, to give me a more specific interface to these services and the other services that I want to make available as a RV through a web user interface. So I just wanted to talk about some of the tools I reference in this video. Some of them I'm not going to go into a great deal of depth with. So the first one is MCP. I'll talk about that a little bit more after this, but MCP stands for Model Context Protocol, and this is a standard protocol for talking to services that sit outside of an LLM or an agent. To build Model Context Protocol based services, you used FastMCP. This abstracts away a lot of the complication with using MCP, so I'll show you how to build a simple service using that. And just to let you know, I actually went through a Udemy course to learn how to do this. I put the link in here. I found that course quite good, so I think it probably told me a lot of the basics about building a MCP service and how to use them. Another tool I'm going to use, and I've already referenced this and talked about it in part 1 of this series of videos, is called Open-WebUi. Down the road I want to create a custom agentic agent for this, for my Scamp, but at the moment I'm going to use Open-WebUi to help test out the MCP services that are working with the LLMs correctly. And Open-WebUi is just an open source AI user interface, and I use it with Ollama hosted LLMs. And the other tool I'm going to be using is Continue.dev. So this is an add-in for VS Code. It provides an AI assistance. I talked about this in part 2 of these series of videos, so I won't go into any depth, but I'll be using this to do some of the coding rather than hand coding everything. Let's have a look at Model Context Protocol. So MCP, or Model Context Protocol, was released as a white paper by Anthropic towards the end of last year. Hasn't been around very long. One thing you have to be aware of is that a lot of tooling and LLMs are aware of MCP, so you may have to use fairly recent versions of tools and LLMs to get things working correctly with MCP. What MCP does is it provides a standard way for LLMs and agents to talk to external services and the outside world. So before, there used to be proprietary APIs from each LLM on how you'd make use of services outside the LLM. Now with Model Context Protocol, if you follow the rules of that, a lot more services are available and everything's standardized, so you can just plug and play with a service that you want to use. So I'm going to be creating the Scamp or RV agent for this, and I'm going to make use of some services that I develop that the LLM can use. To use those services, I'm going to use MCP, and I'm going to in particular use the FastMCP Python library to make developing those easier. So to get going with this, and I'll walk through a demonstration of actually creating one, you need to have Python installed. So I'm using 3.12, but anything later than that would work as well, and have npm pre-installed. Use pip to install UV, ultraviolet, so that's a Python package manager, and they'll be used later on when I create a package. create a project. So if I'm creating a project, I'll walk through doing this. So I'm using VS Code, so I'd create a new project, which basically means opening up a new folder. I'd do a UV init. I'd do a UV venv to make a virtual environment for Python. I'd activate that virtual environment by running the activation script. And I'm also going to add in MCP CLI, which gives me some utilities for doing MCP things from the command line. Let's have a look at that running. Let's walk through making an MCP server using FastMCP. So I'm in VS Code. I've created a new empty folder. I've already installed the prerequisites for coding with FastMCP. So the first thing I'm going to do is do an ultraviolet init. So that sets up the ultraviolet base environment, and I'll also do a ultraviolet v So this is set up a virtual environment, and the last thing I need to do is activate that environment. So I'll do a dot v and the environment's activated. We can see the MCP demos, the name of the environment. Last thing I need to do is install the MCP command line interface. So we can do a UV add MCP CLI. So that install all the packages needed to do FastMCP. So I'm going to make a little MCP server just to demonstrate how you make these. It's going to be I'm going to call it MCP time, and it's just going to return the current system time. So first I need to create a Python file. And for the content of that, the actual code, I'm going to use continue. I'll pop in this prompt, so it's just saying use FastMCP. That creates a tool inside it called getTime, and it'll return the current system time as UTC time in ISO 8601 format. Going to be in chat. I'm going to use GPT-5 again because MCP is so new. I have to use an LLM that has heard about MCP at least, and chat and GPT-5 is fairly recent. So let's run that, see what we get. So that looks pretty good to me, no hallucinations. So let's copy that code, put it over here in our Python program. We don't really need continue anymore. Let's move this around a little bit. And the general format for MCP server is to import the FastMCP class, then set up a MCP object using that class, add some attributes to that object. This is something you see a lot. So in MCP or FastMCP, there's this MCP tool decorator. So this declares that the next Python function is going to be a tool. The definition for the Python function ends up being the definition for the tool. The description down that is used by MCP to inform the LLM what this particular tool does, and there's the actual return based on what I asked the tool to do. So getTime returns the current UTC time in ISO format, and then we run it. That's looking pretty good to me. Let's see if it's going to work. So for debugging, part of that MCP CLI is a dev environment and inspector. So MCP dev and we're going to run this MCP time pi. So let's see if this is going to work as an MCP server. Okay, it didn't like description, so maybe we'll take that out. Save it, try it again. Okay, that's looking more hopeful. So by default, the MCP servers created this way uses the standard I/O transport, which is okay if you're just going to run MCP servers locally. I'll show you later on for my environment where I'm going to run it on a separate Raspberry Pi. I want to run these in http streamable mode, but for now, for testing, let's try standard I/O. Let's connect to that service, and then we can click on the tools button and list the tools. So we see there was a tool defined called getTime, and you remember we had that decorator just before the getTime function, and I can try selecting that tool. It tells me more about what the input and output for that tool should be. I can run the tool, and there we get a kind of what the expected output would be the current UTC time, which is correct, 4 hours ahead of my local time, and it's in standard ISO. So let's have a look at how this gets run on the Raspberry Pi on my mobile setup. So something I wanted to do is make sure these MCP services I create run as web-hosted ones. Makes it much easier to connect to, so I use the http-streamable transport for the MCP protocol connection type, and I got them running on different ports. So we'll have a look at how to write all the changes needed to the code to get them to run as a web-hosted and running on different ports. On the Pi AI, I'm running everything using systemd, so I've created systemd files that all sit in the standard place, etc. Systemd system folder. We can have a look at what they look like to get these fired up. And a note about one more service I run is just a GPS service. So I just have that running continuously in the background. It receives the latest information from a GPS device and saves those latest longitude and latitudes in a gps.json file, and that's what my MCP GPS service reads as the JSON file, rather than going directly to the device. Makes things easier, and if I lose GPS for a while, it can still use the last good GPS results in this file. This is the code for the web-hosted version of, in this case, MCP time. So it looks a lot like what I just showed you. Some of the changes to allow it to be web hosted is when declaring the FastMCP object, I now declare a port. So this is going to run on port 8102. And I also declare a hosts that can use it. So 0.0.0.0 means any host can call this service. Otherwise, it looks much the same. You see the MCP tool decorator, the get UTC time. I've got a different name for it here from the other one I showed you, but basically does the same thing. I also have another tool defined for getting the local time from the UTC time by entering a latitude and longitude. It works out the time zone. And the last thing in here is I set the transport to streamable HTTP, so that tells it to run as a web-hosted service. What this now allows me to do on the Raspberry Pi is to use systemd to initiate this. So start it up when the Raspberry Pi starts up, and have the service always running and be available as a web-hosted MCP server. So I'm using systemd under the Raspberry Pi Linux to actually start up all these MCP services as services when the Raspberry Pi starts up. So this is what my systemd service definitions look like. I won't get into details of systemd, but basically what I needed to do was define the working directory, so where the actual FastMCP Python file sits. And then when I started up inside its virtual environment because it needs all the MCP support libraries. So I run it with the Python interpreter that's running under the virtual environment, brings up all the supporting libraries, and then I run MCP time.py. Just some typical systemd stuff. So if it fails, it always restarts, and the user in the group that it runs under. And that seems to start it up fine, and we can have a look at one of these running. So this is how I found a way to test these MCP servers that are running on another host as streamable HTTP. So what I did, I just had another project here, so I have like a dummy MCP server defined here. It doesn't really do anything much at all. And then I can use the MCP inspector on that dummy service. So I run it as dev. So we'll fire that up. So at the moment it's in standard IO mode because that's kind of the default. So I'm going to go to streamable HTTP. I've already put in the URL, but this is the URL on my Pi AI machine for the MCP time service, which is running on port 8102. So I can connect to it. If I look for tools and list tools, I can see the tools that we just saw in the code. And if I run, say, the get UTC time, it's returning the right values. So this is a way to test things that are running as HTTP servers on other hosts. It seems to work. There may be a more elegant way of getting it going, but this works for me. So if I just do a system control and group that, I can see what services I have running. So you can see all the MCP ones that I have running, the 4 MCP services, and also the GPS logger service. So that's the one that's continuously getting GPS locations and putting them in the GPS JSON file. So I've got all the code and the system definitions for all these services. Time GPS holds the code and services for the time, MCP time and MCP GPS service and the GPS logger. MCP PA state parks holds the code and a database for PA state parks, and MCP RV parks has the code and database for RV parks. I've actually got 4 states worth in there. So let's have a look at how we add the MCP services to Open-WebUI. Like I said, I'm going to use Open-WebUI at the moment to test the services working with the LLM. Down the road in the next video, I'm going to actually try and make a custom agent to use the LLM and the services. But at the moment, Open-WebUI is a good generic front end to do that with. So what I need to do is register the tools or the MCP tools with Open-WebUI. I actually went through this video twice before. I was using MCP 0, which was a proxy for getting Open-WebUI to work with MCP. But in the last month or two, Open-WebUI, they've put a native MCP tooling into the actual application. So it's become a lot easier to be able to connect up MCP services with Open-WebUI. So the version of Open-WebUI I'm using is I can look in settings, about, I'm on 6.34. So with this version, when you go to admin panel and settings, you should see external tools. There's the 3 tools that I've set up already. So I've still got to do 8104, which is the RV park tool. So let's add that in. So first select the type. So this is the new thing, is you can now select MCP as the type. Put in the base URL, so http:// AI 8104 is my port, and MCP on the end. Got no authentication. I'll just put the port number as the ID. Call it RV Parks. Looks good. I'll make the visibility public so anyone can use it. I'll verify the connection. So it tells me connection successful when it can reach that MCP server. So I'll save it. So I've now got these 4 tools as my available tools. So if I now go over to create a new chat, at the moment I'll use this LLM, Cogito 8B, seems to work okay with MCP tools. And if I click this little icon here, it shows me I've got 4 tools available. None of them are turned on yet for this chat, so I can do things like switch on all these. All those tools should now be available for use in the chat. So first I'm going to warm up my LLM, so this really just loads it up. So I just do a hi. So it should be loaded into the Olama now. So first thing I'm going to ask it, seeing I've got the tools, is what is my location? So that's good. You can see it used the 8101 tool, get location, return my longitude and latitude. If I click on the source and look at that, it shows me what it actually sent to the tool and what was returned. So that's good. I should be able to find out what RV parks are close to me or state parks are close to me. So let's do a what state parks within 20 miles of my location. Let's try that one. So here it had 2 sources, and it's using the get parks by distance, and you can see it passed my location onto it as input parameters, 20 miles as a parameter, and these are the results that came out of the MCP tool. So that's going okay. Let's try a new chat. So I'm going to have to tell it the tools exist again. And this time I'm going to do something more complicated. So it's forgotten my location from the last chat. So I'm going to ask it what state parks are within 20 miles of me. And some tools with good reasoning can work out that, hey, first I need to find the location. Then I need to call the get park tool. But you'll see a problem with small LLMs here. So again, I'm running this with an empty context. It's going out. And some LLMs are smart enough to work out that, hey, first I need to get the location, and then the next call will be to the get state parks within 20 miles of my location. So you see it failed here. It actually did the get location part, but here you see it's passing nothing to the state parks by distance. So it didn't realize that it needs to do the first call to get location first before it does a call to get parks by distance. And That's what I'm finding as a problem with some of these small LLMs. Maybe the reasoning is not that great in small LLMs, but let's compare it with a full-featured LLM. So I have got GPT-5 out there as an option. I'll start a new chat. Declare that I've got core tools here. And I'm going to ask it the same thing. So again, this is going out to a GPT-5 Nano that's out on the web, and it's pretty full-featured LLM and fairly recent one, so it probably knows more about MCP and tooling than the local one I was using. So a bit more chatty, this one, so I have to tell it, yes, I do want to find state parks within 20 miles, Pennsylvania state parks. And it got there by calling the same tool. So this is why I probably want to do a front end. So I might want to, until the tool's LLM's reasoning is good enough to sequence these calls reliably, I think I might have to put together a little workflow for these sort of questions where it knows first to load up the location and then to go call the tool. But that will be in the next video when I start looking at that in more detail.